Hi and welcome. This time around we have a project that my wife's been pestering me for a long time, and you guys now equally pestering me, getting on her side. So we're working on the stand for the bell I made out of the dive tank, which is right there. It used to have a threaded in piece in the top that I thought was gonna, use to hang the part, and I still have the threaded piece. However, it affected the ringing of the bell. Removing it made the bell ring a whole lot better, so we're going to leave it out because ultimately we want the sound to be decent, and now it actually sounds pretty good. So we got to figure out how to hang this. This 1/2 inch plate right here is going to be turned into a stand and a platform that this will hang under, that the bell itself will hang under. There are the legs for the stand. My wife wants it 6 feet tall, which is really tall. I think I convinced her to go down to 5.5 feet, but that's a lot of weight to have hanging up high, especially sitting in a planter. So I've got all those considerations to take into account. Also, I originally wanted to do this with a single pole design that was going to be put in concrete, buried, but she wants this thing to be mobile to switch between planters. So she wants a tripod, which I'm surprised because actually she originally wanted 4 legs, but I convinced her to go to tripod because tripod's easier to make stable than 4 legs. She wanted to be able to mobile and big. So this stand will ultimately hold a plant on top of it. It is not going to be the whole thing. You'll see as I show you next what my layout's going to be to convert this into the mounting top plate that the bell will hang from. If you happen to see my dive bell project, here is the piece that threaded inside. You can see that's the inside of the dive tank. And I had 2 holes because that's how I was going to hang it. And this piece just threads in here like this. It's pretty tight now because this thing's been hanging out without it for a long time. But I could actually easily tighten that in. But it affects the ringing of this thing quite significantly. So I don't think we'll be using it. We'll find a way to hang it by probably a hole going all the way through to both sides, some sort of central support. But this thing weighs quite a lot. So that's a whole nother challenge. Also, having it up as high as she wants it also is going to be a challenge, especially if it's not anchored in concrete or something and just mobile. So let's see what we can come up with. One more thing, you'll notice that there's so many scratches in this dive bell in the paint job. And it's not because it's been abused, it's because this transparent paint that I use that shows the underlying metal I thought would be really cool, so it's very shiny, is incredibly delicate paint, and you just barely bump it and it flakes off. It was not a good choice, so if you're thinking about using it, make sure you use it in a place where it doesn't get bumped by anything, because this is probably like 3 or 4 coats, and it comes off all too easily. So going for an equilateral triangle. So we got this brown and sharp angle divider here set for 60 and 0, so 5 minutes per lamp. So one division is 5 minutes, so we're right on the money. And this doesn't need to be precise, obviously. This is a garden implement, so it doesn't have to be super accurate, but we're going to try and get close. Using my long scale here, drawing lines extending out the 60-degree angles I drew from the corner, we're going to make an equilateral triangle. This was cut to be 2 feet by 2 feet, but the vendor I buy from always gives you a little extra. This is a 1/16 over on each side, so these are 24 1/16 by 24 1/16, so that's correct. So we're going to have to cut off all that excess. That'll be fun. And I also need to know the center point on this guy. And I'm also going to need to know 4 inches down each one of these edges, because we're also going to cut that material off because we're going to make square corners on this guy. So I might start by cutting the corners off because that'll let me save a bunch of material. So let me draw that up next. These lines might be a little faint, so I'm going to cut off the top of this triangle, this equilateral triangle, which means now that I've marked this out, rather than cut here and then cut the tip off, I can save this whole piece of material, which is a nice piece of aluminum. We don't want to waste that. So we're just going to cut straight across here, and that'll solve that. Then we got to remove this piece here to here, and then I'm going to cut this section off. So I'll probably start by cutting that section off there, that section off there. I also drew some right to find my center. This one I got wrong the first time, but there's the center point where they all intersect. That's pretty good for meeting. So all 3 points are meeting at the same point. That's my center of gravity and also my center point of this tip truncated triangle that I've got going here. I'm gonna have to take the rest over the bandsaw and cut it off. And then ultimately we'll take it over the mill and clean up the sides. So I'm gonna leave some extra material to take off on the mill. This is my reference side, this flat side here. This is not perfectly cut material, but again, this is a garden implement, so it doesn't have to be perfect. We're well within 62 thousandths of accuracy, so I'm happy. I don't know if I've ever shown this, but this sliding bandsaw which the blade moves forward like this. It's easily converted into a regular style bandsaw. The throat depth is not very big. It's like 14 inches, which is actually going to be a problem for me. That's good to notice before I start. Anyways, this piece comes off, the clamp comes off by just pulling that pin out. Now the clamp's free. This guy, I added the centering pin here, which I reamed in place to find the 90-degree square center each time. I mean, there is a scale down here, but relying on that was a pain, so I pinned it. It has a pin also in the center that it rotates on. Now you can see where we're headed. Take the sliding table, put it all the way forward, like so. And actually, with this 1-inch blade, which it's not supposed to have, it's only supposed to go up 3/4. Although I asked the vendor if I could do that, and he said sure. But we're gonna have to space this guy out a little bit, space it back some, otherwise it will cut into it. And it's held in place by that little sliding piece back there that locks behind it and prevents the table from going, or the blade from going back when you push on it. And then you've got yourself a regular bandsaw. Let me set that up, bring you right back. Found this big chunk of aluminum that I want to use as a spacer block, but it's too tall this direction, so I'm just going to cut off a chunk down here because it was sticking above the edge of the table, which means anything you slide would run into it. So we're just going to cut this guy off first. It's, I don't know, what is that, 3 inches thick by 6, 3 by 6 roughly. So we're going to cut off a good sized chunk of it so that it'll be just below the table level, and we should be good. So one of the beauties of this kind of push saw is that it pushes the work into the fence, so you can get away without clamping things down if they're big and sturdy enough, and they won't go anywhere during the cut. Now it's risky, I suppose, if the blade got caught or something, but I've never had a problem with it. It's been very reliable. Big slab of metal we're cutting off there. We're about 3 or 4 minutes in. This is a 6-tooth blade, 1 inch thick. This bandsaw is designed for 3/4, but the manufacturer said I could put 1 inch, it just wouldn't be supported the whole way, and I couldn't set the tension to maybe what a 1 inch would use. I do 25,000 PSI for this, which I think is a little low, but it cuts right through, and it cuts a very straight cut with a 1 inch blade, which I like. And there we go. All right, so now I'll use this as my spacer block. Another solution would be to take this 1 inch plate here, drill and tap it, and have a bolt, adjustable bolt that comes out here that'll press against this piece right here. I'd probably want to support this with a little something so it didn't scratch it, but this is a pretty sturdy piece, and that would also work. That'll be a future project. We'll have to remember that. So you can see what kind of limitation there is on the throat here between this blade here and this upright. Since it's at, I don't know, 45-degree angle, I can only fit that much material in there, which I think is like a foot. But fortunately, the cutoff portion of this down here is less than that. So I'll just have to keep the excess off to the left, which means my light will have to move. It's going to be tight. Okay, done. Holy cow. Here's what the top of the stand looks like now that it's been rough cut. Still need to mill the sides. I have one reference side, which is over here. Every other side will be referenced to that side. Just got to take a little bit of material off of each of these sides to get it flat and square, just so it looks nice, because that's what we're shooting for. There's going to be holes cut in here where the legs will be mounted. Perhaps next I'm going to work on the leg mounts, because I've got to figure out what diameter I want those, because I'm going to drill a hole through here at 15-degree angles so that the legs come out, that it's not dead vertical, give it a little support. So I'm looking for a hole size that'll match one of my annular cutters, and then I'm going to weld it in place, and I'm going to use some solid aluminum that will weld here and then fit inside of my leg material, which is 1 3/4 inch tubing. And the height will adjust as necessary. I'll start with 6 feet. I've also got to make feet for the tubing because I don't want just plunging into the ground, so I need to do that as well. Cutting out some 2-inch solid aluminum stock for the feet and the adapters, but right now it's just going to be for a test cut. Got a pretty long piece here. I actually have 2 of them. Next up, we're going to make some very simple feet to start. So we'll start by facing the material. I guess it doesn't matter if this is not perfect, nice surface, because this is the inside of the foot, so it really doesn't matter. This insert is a really cool insert for facing. I forget who brought this up. One of the other YouTube machinists brought this insert up, and it is slightly positive, and it makes really clean surface finishes, even on hard to cut materials like cold rolled. All right, so we're going to start with a, this is 2-inch material. We need to go to 190. Correction, we need to go to 1.490. So that's a 1/2 inch of material being removed. So let's see what we can get away with. Here's 150 thousandths cut. You know, I'm going to bump up my feed rate. Let's take this back to 150 thousandths depth of cut. And we need to go in 1 inch. Okay, not even much spring back. So I don't know if you can see this, but it doesn't cut on the way back, leave a mark. If we were having flex in the machine or the cutter or the part or all the above, when you're done with the cut and you come back, if you come back straight without pulling the cross slide out this way, this direction here, then what will happen is it'll cut as it comes back, as everything springs back when there's not as much force. There we are. Now when I come back, you see it's not cutting the material? That means that I didn't load everything up with too much force in the cut. Bring my test piece over. So we want this to be snug. Now, as I recall, this material that's extruded, it measures 1.490 with a 3-point mic. But when I just use calipers, it goes from 87 to 91. And that's because I think it's actually oval, which wouldn't surprise me, just ever so slightly. Okay, it looks like I'm 1,000th over. Yep. All right. It sucked in an extra 3/10, so I might have overshot now. Let's see what happens. I think with the oval shape that pushing this guy in there, this should be right on size, maybe under a couple tenths. And since it's oval by a couple thousandths, I think this will tap in and stay pretty well. Yeah, it's still a press fit. However, it starts now. So I can pound this guy in and I can feel that it's touching at only a couple points because this is oval. So I'm guessing probably a lot of them are oval. So let's just finish off this part here. Oh, and curiosity, let's see where I ended up. Half a thou under, actually. Okay, we're gonna part this guy off. I didn't even catch that. I can't part something off this big with this parting tool. Oh, that's funny. And I actually ran into the edge there. That's kind of unfortunate. Nothing a little Scotch-Brite can't clean. I found a different kind of parting tool that should go deep enough. But with this guy, I think I'm gonna have to go much slower. This thing will do 2 inches of stick out. It's hard to imagine it'll actually work if you do that, but and there we go. Wow, nice. There's 1 foot down, got to make 3 more of these. Making number 2. There's 2. Even though I went to the same 0 on my DRO, things cut a little differently this time. Not quite sure why, maybe because of the depth of cut. This one is like 3,000 smaller in diameter than the previous one. It fits enough to stay, but it's not as tight as I would have liked. I'm a little disappointed by that. Next up, we need to make the adapter shafts. And that's going to be made out of this 2-inch solid aluminum 6061 here. One end of it is going to be fitting in a hole that's cut at 15 degrees here for the leg going out. I didn't want to weld the legs in solid because I want to make this thing so I could take it down and store it if I had to. So 4 inches of this is going to be taken down to the inside diameter of the tubing I'm using, which is right here, which would be about 1.490 is right on the money, so probably like something like 1.487-ish. We'll try it and see how tight that is. And then the other end will be 1.75 for the hole I'll be drilling here, and I'll weld that end in. So this will basically have 3 legs sticking off it that I can mate with the tubing and extend that down 5 and change feet. I'm lucky the hole through my spindle in this lathe will handle this 2-inch solid material. That way I can leave one long piece rather than having to cut out a bunch of pieces. You know, cut one side, flip it over, cut the other side. This way I can just make it all and part off each piece all in a row, which will be really handy. So that's what we're going to do here. We got to take this down to 1.487-ish. 150 thousandths depth of cut. Same feed rate, different depth of cut, not breaking chips. All right, so you can see here that this is even, because this stuff is not completely round, it's out of round by a few thousandths, it pinches. So this is a little bit undersized. I think the proper size for the largest dimension is like 1.493. But I have to take it down a few more thousandths because I want to be able to assemble this easily. So I think we're going to take another 3 thousandths, and well, we'll just try 2 or so, and that should make it so that we can slide this on a little more easily. I didn't face this side because it's inside. It's going to be inside the tubing. No one will ever see it. It's still going to be pretty tight to get it on and off, but I don't want to. I don't want to slop around. So, okay, it's just a little chamfer. This side here is going to be reduced down to 1.75, which is the outside diameter of this guy. So this will mate up and go flush. Quick chamfer. And just to support our friend Quinn Dunkey, we're going for a Yahtzee here. I've never played Yahtzee, by the way. Here's our part. Just have to make 3 more. Here we go.